Hi, everyone, and welcome to KotlinConf. It's genuinely so great to be here together. I'll be honest, I can't wait to spend these next couple of days talking to all of you, really geeking out, probably until my voice gives out about this programming language that we all love. And it's a programming language that underpins so much of modern life, too. When you're paying for coffee, when you're getting on commuter rail, when you're watching a movie on an airplane, and yeah, even when you're paying your taxes, there really is a pretty good chance that Kotlin is involved somewhere in that process. And I think for all of us as the developers of these kinds of systems and so many others, it's particularly exciting to see Kotlin everywhere, having this widespread impact. Because a programming language really does shape so fundamentally how we as developers can approach problems, right? How things are expressed in code has these wide-reaching effects on how we can manage complexity and how easy it is for us to build reliable software. And with Kotlin, that's exactly what we at JetBrains continue to build and to invest in, so that you get a foundation that you can trust where it doesn't matter if you're building small prototype utilities, if you're building your medium-sized multi-platform apps, or your largest enterprise projects. You just always have a great, fun time. And one where you can be confident in what you ship to users, and you feel comfortable owning the code. And there really are so many different aspects that play together to achieve that. It's, of course, the language itself and how it evolves, how its syntax should adapt so that reading and reviewing Kotlin code is easier and faster, so that all of us as maintainers can quickly understand the impact of a change, and where we don't have to care if that change was made by a colleague, by an AI agent, or if we're being honest, by ourselves like 2 weeks ago. Beyond that, it's also about the tooling and the ecosystem and how it should evolve around this language, right? So that getting started is quick and growing your projects is easy. It's about AI-driven development, AI workflows where you use agentic development, and of course, how we can make Kotlin the best language for you to build your own agents. And it's about Kotlin across all of its platforms, from backends running in data centers to the phones in our pockets, so that you can reach your users wherever they are. It's a lot of things, and I'm really excited to get into it. So who better to really take us in than Michael, our lead language designer. Please give him a hand.
Good morning, everyone. It's so great to see you all. To get started, let's take a look at Kotlin's evolution and how it fits into the world we are in today. Let's consider the typical development path. When we build applications, we begin by choosing a platform: mobile, backend, or web. Next, based on factors like portability, specific safety and performance requirements, the community, we pick a language and its ecosystem. For me, it all once again boils down to trust in the technology. And with AI agents lifting the level of abstraction, that becomes more and more important. And with Kotlin, we aim to provide that trust at every level. At the language level, when code compiles, the compiler has already verified a lot for us. And by carefully choosing and refining language defaults over time, we want to bring more and more safety for your programs, with features like name-based destructuring, must-use return values, non-nullable types, or structured concurrency. And as a developer, you always spend time more reading code than writing it. And it's good that we invested in clear syntax and the right defaults from the start, such as extension functions, named parameters, string templates, and so on. So essentially, ergonomics and safety are the principles that guide the language at its very core. These are the things that allow us to stay confident in the systems we build. And today, we are happy to share the next step in that direction. Please welcome Kotlin 2.4. And now, finally, I want to show you the main language feature updates in this release. And first of all, we are stabilizing context parameters. And to showcase it to you, let's imagine I have an interface session that is typically injected in my application. And in this interface, we expose payment settings, in which you can check whether a payment provider is supported or not. Next, when we actually perform the check, we have to go through session, payment, and only then do the check, whether the payment provider is supported or not. And it's all valid. However, from the core logic perspective, we are really interested only in this check, whether the payment provider is supported or not. The rest is just wrappers and supporting code. And this is where our extensions, and now extensions with context parameters, can help. So let's extract the necessary logic into the property called enabled. But since our extension receiver is payment provider, we need to get session somehow. And here, it can be provided in the form of context parameter. This allows us to have two receivers and enrich the payment provider API surface naturally. So our call side will then turn into a simple check, but here of whether the CodePay provider is enabled or not. And this is what we wanted to have in Kotlin. Focus on the core logic of your application. And to put it simply, context parameters enable more consistent and idiomatic Kotlin across many APIs. The second feature we are stabilizing is explicit backing fields. Sometimes we need two properties. One is part of the public API, and the other is an internal implementation detail. And we call this pattern backing properties. In this example, we have a public property users that returns a read-only set, and a private mutable property that we use to modify the value internally in the function register. The drawback is that we have to maintain two separate properties representing the same state. And of course, this introduces boilerplate, but also it makes refactoring slightly harder, since every rename, type change, or even moving these properties around now requires extra care. So starting with Kotlin 2.4, you can declare explicit backing fields, and they let you define a single property whose backing field can be modified internally, while the property itself is exposed through a more restricted type. Explicit backing fields reduce the number of entities, and they let you keep mutable state safely encapsulated. And beyond the features we are stabilizing today, we are also exploring a few experimental ones. And one of them is about working with data. We often want model domain values and simply hold data which is then passed around in a program, maybe money, numeric types, colors, and so on. And today we typically do that with data classes, which have been incredibly popular in Kotlin, because using the declared properties, amount and currency here, the compiler can automatically derive such functionality as equals hashcode into string, component functions for positional destructuring, and copy function to make a copy. However, over the time, we also learn how copying and destructuring can be done in a safer manner with fewer auto-generated methods. And for that, we are exploring multi-field value classes. So let's take a look at their building blocks. First, as with data classes, the compiler will auto-generate equals hashcode into string, saving us from boilerplate and mistakes. Next, based on value classes use name-based destruction by default, which means that you destructure using property names such as amount and currency here, but not amount and country, as there is no such a property. This makes destructuring safer and avoids generating additional methods, unlike data classes. And further, one of the core principles of value classes is that they don't have identity. In practice, this means two things. First is that they are fully defined by their properties. So if properties of value classes are the same, then their instances are interchangeable. And because we normally don't rely on identity when working with data, value classes can help prevent subtle bugs. And second, there is also a long-term performance story here. As the JVM also evolves with value types, Kotlin will benefit from optimizations like scalarization and heap flattening. In many cases, it means that creating a value class instance won't be resulted in a new object at runtime, making these abstractions very, very efficient. So overall, the direction is to make value classes feel as natural as regular classes, just with better defaults for modeling data and better optimizations underneath. One part that is still evolving is updates, and specifically how to make modifications of value class instances convenient and familiar. For that part, feel free to join Marat's talk about mutable value semantics. We only touched a few updates from Kotlin 2.4, and there is actually way more in progress, and I invite you today and tomorrow at the Language Evolution booth. For us, language ergonomics and safety are the foundation. That's where we invest our resources, making sure that we can get clear and correct code by default. And on top of that foundation comes the next layer, Kotlin ecosystem. And with that, I'd like to hand it over to Vsevolod, who will walk you through what's happening there.
Thank you, Michael, and good morning, everyone. Kotlin turns 15 this year. For these 15 years, we've been creating Kotlin with tooling support in mind, to provide the best experience, to be compatible with modern tools, to be seamless. And modern tooling isn't just IDEs or build systems anymore. It's also agents, AI skills, and all kinds of integrations. And even though modern tools are constantly changing nowadays, our core principles do not. And the Kotlin ecosystem is what makes them work for you every day in any environment and with any kind of tooling to provide you with consistent development experience. As one of the examples, last year, we announced experimental build tools API. The idea was that with a clear boundary between the Kotlin compiler and any build tool, we'll be able to provide support equal and unified support of development experience for all users. The same performance, the same incremental compilations, the same performance, the same compiler caches, the same incremental compilation. And it's paid off. Since the last KotlinConf, build tools API is now used in every major build system. And it doesn't just unify and improve build experience. It enables all of us to do more. Maven now has concise and smart Kotlin defaults without a lot of extra configuration. Bug 2 enjoys Kotlin incremental compilation at scale. Mill adopted Kotlin with ease. And in Gradle, thanks to build tools API, we've been able to decouple Kotlin language and Gradle plugin updates So now you can enjoy the most recent Kotlin language version while keeping your Gradle toolchain as you please. And with such a solid foundation, we are now actively collaborating with open source community to provide first-class support of Kotlin in official Basel rules to enable Kotlin in the largest code bases with tens of thousands of modules. And every build system, it comes with its own pros, cons, and use cases. And of course, we are committed to support all of them. But often, our projects don't need all the complexity that comes with using a separate build tool. What we really need is just entrance into Kotlin, one cohesive place to start. A single command for everything, from creating and running the code, an app, to generating code, formatting code, generating documentation, and even integrating with agents, with no extra choices to make, just Kotlin. So please, welcome the Kotlin toolchain. A main entry point into Kotlin. Starting today, you can already use it for JVM and multi-platform projects to build, run, and test your apps. These are all things we built in the Emperor project, which we are now moving directly into the Kotlin toolchain, making it one seamless experience. And that's only the beginning. In the future, the Kotlin toolchain will help you with integrating with language servers, AI skills, managing native dependencies, and so much more. And of course, it is not just limited to the command line interface. As always, we bring deep IDE integration to provide the best out-of-the-box experience possible. That's our vision. The full power of Kotlin at your fingertips, right out of the box. It's already in alpha and is rapidly evolving. So check it out and stay tuned. With all these build capabilities, the next natural step is to create something, to explore, to prototype, to build. But in order to build something, you have to know what to use and how to use it, to read the documentation. And of course, we're not really doing that. As they say, 2 hours of debugging can save you up to 10 minutes of reading documentation. And documentation, it's all over the place. Some of it is on GitHub pages, some of it is on the official Kotlin Lang website, and some of it is on GitHub, on Keynote or Calypso sites. Not great, not terrible, definitely not consistent. But now we have a tool that always reads the documentation and that suffers when it cannot find it. An agent. And its inability to consistently discover documentation just makes our development experience worse. After all, what uses AI if it's not reading documentation for us? To help you to address that, we're introducing the Kotlin documentation model, a core part of Kotlin representing a machine-readable documentation, a KDoc jar. It is a specified, documented, and backwards compatible format that will be built and published along with any Kotlin library, to later be consumed by IDEs to help you, by Calypso to host documentation in the web, and by agents to help them to consistently discover and properly use your APIs. The Kotlin documentation model will definitely improve our tooling experience. And at JetBrains, we love great tooling, and we keep our work to make sure that IntelliJ IDEA is the #1 choice for Kotlin development. But our language, it is not limited or bound to a single IDE or editor. And we want you to be able to enjoy consistent development experience, no matter the environment you chose. This is why I am particularly excited to announce that the Kotlin language server is no longer a wild experiment, but a solution we are committed to, and we are promoting it to alpha. It is now backed by the full power of the IntelliJ engine, from code completion to very intricate diagnostics. When a new Kotlin feature appears in IntelliJ, Be it a new Kotlin version support or a coroutine-specific hint, it will appear in the Kotlin language server too. And even in alpha, it gets support for so many more features. Maven support, code formatting, coroutine diagnostics, and even basic Android input. And starting this week, the official Kotlin language extension is available on the Visual Studio Code marketplace. And of course, you can use the language server as a tool in your favorite coding agent to help it with documentation, symbols information, and the full power of IntelliJ. The language server definitely helps tools to understand code better. But what about helping developers to do it better as well? Especially now, when even more code is being written or generated than ever. And it is much more easier and much more pleasant to read and to understand the code that is consistent. So you can spot the familiar patterns and idioms, focus on the semantics, and trust the result. To help you with that, JetBrains and Meta, as part of the Kotlin Foundation, started the process of standardization of KTFMT and making it a core, default part of Kotlin, the Kotlin formatter. We are starting with moving KTFMT into the Kotlin organization on GitHub. Then we'll revisit our default Kotlin coding conventions. We'll integrate it into the Kotlin toolchain, and later we'll enable it by default for all new Kotlin projects, transitioning the ecosystem to a state where code style is not a code review issue, but a tooling matter, consistent and fixed by default. The Kotlin Foundation keeps recognizing significant contributions to the Kotlin ecosystem through its grants program. So please, let's applaud to the last year Kotlin grants winners, these beautiful libraries and tools. And this year, we are continuing the grants program and welcome you to apply with your open source Kotlin projects with a focus on multi-platform libraries, code quality, and LLM enhancing tools. And here, I'd like to invite Jeffrey to the stage to talk more about Kotlin journey at Google. Thank you.
Good morning. At Google, we've been fans of Kotlin for a long time, using the language in production since the very early days. Today, Kotlin powers the Android apps that you use daily, from helping you navigate around the world, to stay up to date with the latest news, to, most importantly, stay connected with loved ones. With 92% of pro developers writing pure Android apps using Kotlin, and 86% of them reporting that it's their primary language, it's important for Google to contribute back to this project. Our most recent largest effort has been collaborating with JetBrains on the K2 compiler, an important piece of infrastructure that underpins many of Android Studio's most important features. Since we released K2 stable in Android Studio, we've seen near universal adoption. And last quarter, our engineers were finally able to remove over 10,000 lines of legacy K1 code. With this project now completed, we've been able to pivot to performance work. In Kotlin symbol processing, which is Kotlin's alternative to Java annotation processors, which is built and maintained by Google, we're able to save off 17% of build time for complex projects. In R8, which is Android's whole program optimizer, we've been able to add a new optimization to remove reflection use from logs in the coroutines library. And this has shown 50% improvement in composed benchmarks tests. And if you haven't turned on R8 in your own project, you should really consider doing so. Recent case studies, such as the one with Reddit, has shown that apps who adopt R8 see faster startup time performance, fewer app not responding issues, less jank, and even higher ratings in Google Play. Coroutines are now critical beyond Android. In Google Search, the team is rewriting their web serving stack using Kotlin and coroutines to build a modern, high-scalable service. Just in the Google Search team alone, we see over 600 engineers contributing Kotlin code on a weekly basis. In fact, we now see more Google engineers writing Kotlin code for the backend than for Android. Our internal monorepo now has over 88 million lines of Kotlin code, making it the fastest growing language in the last couple of years. Another great example of Kotlin adoption beyond Android is Kotlin multi-platform for Google Workspace. Google Workspace has been working on adopting to Kotlin multi-platform for the last couple of years, and I'm proud to announce that Google Docs is now 100% in production for both web and iOS. The success of Google Workspace has allowed us to move more libraries to KMP, such as data store, room, paging, and navigation. And room and data store now recently added WASM and JS support, allowing you to abstract your storage solutions over all those target platforms. On Android, we're moving forward with Compose first. We have worked hard on Compose feature parity and performance, and Compose can now support almost all Android workloads. With that, views are in maintenance mode. Of course, existing code APIs remain, but any new libraries or tools will focus on Compose exclusively. We're working on AI skills to help you migrate your Vue code to Compose. JetBrains and Google are working together in a single code base for shared code between Jetpack Compose and Compose multi-platform. And Google is now using Compose multi-platform desktop to build our Gemini UI in Android Studio. Regarding AI, we know that most models are primarily evaluated and benchmarked for web development. To bridge this gap, we recently released Android Bench, which is a suite of real-world tasks to help evaluate various models against Android development, giving you a way to see what the state of the world is, as well as pushing the frontier forward for model creators. To make sure that agentic agents can work with their environment, we released the Android CLI. This is a suite of tools that allow you to create modern Android projects, launch emulators, deploy your APKs to running devices, and it comes with a set of skills and documentation to make any agent better at Android coding. Android CLI can be used by both people and agents. While the Android CLI allows any agent to get better at Android coding, we hope that you give Gemini in Android Studio a try as well. We've leveraged the power of the IntelliJ platform, such as fast indexing and advanced debuggers, to build a rich agentic experience and top that off with Android-specific AI features, such as UI testing through Journeys with Gemini, Android Gradle plugin upgrade skills, a new project agent, and many more features. Our engineering team has been dogfooding these features. They're reporting a higher level of productivity, and their code contributions come with a better set of unit tests. So give it a try. At Google, we took an interest at Kotlin early on. Not only is it a powerful language that continues to evolve, it's become a community of innovators who work together and share their ideas. And we're looking forward to share our own experience here at KotlinConf. We have several Googlers presenting on their work, and we'd love to chat with you at our booth. With that, I'd like to introduce Svetlana onto the stage to talk about AI tooling in Kotlin.
Good morning, everyone. As part of JetBrains, Kotlin has always been built with tooling in mind. And now, a whole bunch of next-generation AI tools can empower your Kotlin development. Let's take a look at them. Let's say you're building your Kotlin application right now. And instead of writing code by yourself, you're instructing your agents to implement it in Kotlin. And the good news is there are a lot of agents that work really great with Kotlin. Of course, we want you to be able to use any agent right inside the IDE. That's why JetBrains is co-leading the development of an open standard. It's called Agent Client Protocol, or ACP, and specifies how IDEs and coding agents communicate. You simply pick an agent, and you start working right away. It's about having an open ecosystem where you're not limited to a specific agent, model provider, or payment system. You can use the JetBrains AI subscription or bring your own keys to use with different models and agents. And we want to enrich this agent ecosystem with the power of IntelliJ IDEA, the power of a code understanding system built over 25 years. Coding agents should be able to navigate your Kotlin code intelligently and find usages, perform refactorings, understand structure, do different things from simple refactorings like renames to more complex ones. And we're turning these capabilities into agent-ready skills and we're going to bundle them in the IDE for your agents to use. We focus on choosing those to deliver measurable impact, making agents faster and more token efficient. We used to say that IntelliJ IDEA makes you more productive. So now we are taking it a step further. We wanted to make your agents more productive too. It's especially true for Junie, a coding agent from JetBrains, which is deeply integrated with JetBrains IDEs from the start. Even if you use Junie's CLI version, it can connect to the IDE to get the full context. Junie works with different LLM providers. You can pick the best model for the task, whether it's a top tier, a local model, or the one hosted on-premise. You can use it via subscription or with your own keys. Our benchmarks show that its performance is on par with the top competitors, and at the same time, it can be up to 4 times cheaper if you use the top models for planning and the cheaper models for code generation, which might be pretty useful if you don't have an unlimited supply of tokens to burn. Junie works great with any Kotlin project. And now it gets special support for Android. Makes sense, since they're both green. When you first start using Junie for Android project, it suggests relevant skills. And you can get straight to work. Let's ask it, for instance, to add talk filters to the KotlinConf app. While working, it interacts with the emulator, taps around, and takes screenshots to verify the logic works. It can even check that the rotation keeps the choice. Junie with Android support is available in EAP now. So please come to us to join the early preview group and share your feedback. So now you are now using agents, and you are becoming more productive. One dimension when it comes to scaling agent-based development is that you can ask several agents to do different tasks in the same code base. But how to organize that? It adds an extra layer of complexity. You don't want your agents to get in each other's way. At JetBrains, we're building an agentic development environment, JetBrains Air, for you to effectively work with agents. You can ask several agents to work in parallel on different tasks, like iterating on unrelated UI elements in your compose code. You can start different agents in separate Git walkthroughs or Docker containers. Codex, Claude Agent, Gemini CLI, Junie, and other agents can all execute independent task loops so that they don't conflict with one another. You can see which tasks are running and which task needs your attention so that you can quickly switch to it while the agent keeps working. Air then helps to bring your changes back to the main copy. To share progress across your entire Kotlin team, soon you'll be able to use cloud agents and even start and guide them directly from the browser. You'll also be able to configure agents to automatically run repetitive tasks on your code base. JetBrains Air itself is free, so you can start experimenting today. You'll need to pay for the tokens, though. For some reason, they are not free. However you work with agents, we support you on your journey. And we don't do that alone. Please welcome Christian from Anthropic, one of our key partners, to share how they empower your Kotlin development.
All right. Guten Morgen, Munich. My name is Christian Ryan, and I lead Anthropic's applied AI engineering efforts here in Europe, which means I spend most of my time working with developers like yourselves, figuring out how to get actual value from Claude in real code bases. And there's no community where that conversation is more fun and exhilarating to have than this one. All of you who are here today expect tools to be thoughtful, expressive, and to simply just work. And that's exactly the bar we hold ourselves to with Claude Code. Now, the collaboration between Anthropic and JetBrains goes deep, and that's what we're going to talk about today. And to begin, let's take a little trip down memory lane. Back in late 2024, when we shipped our official Java SDK, we decided to build it in Kotlin. It gave us an ergonomic, concise, and null-safe language to work in, and thanks to Kotlin's Java interoperability, consumers still get a clean Java API to work with. So whether your team writes Kotlin, Java, or anything else on a Java platform, it's an easy pickup. A short hop later, when we open-sourced the model context protocol, JetBrains were actually the ones to build the Kotlin MCP SDK. And today, it lives under the official MCP GitHub org. That's the kind of contribution you only get from a real engineering partnership. Beyond libraries, though, Claude is native in IntelliJ, Android Studio through the Claude Code plugin, and a first-party model in both Junie and JetBrains Air. And on the CLI side, our Claude Code plugin wires in JetBrains' official Kotlin language server protocol, so Claude Code understands your Kotlin projects in depth. As you can see, this is a partnership on multiple fronts, and it's showing up in the libraries and the tooling layer. But at our core at Anthropic, we're a research lab, and nothing epitomizes a relationship more than evals. And we want to honestly know how good our models were at Kotlin. And in the context of this endeavor, JetBrains built their Kotlin software engineering benchmark called Kotlin Suite Bench. It's a benchmark consisting of 110 real-world engineering tasks pulled from actual Kotlin repositories. Real bugs, real features, real PRs, the whole lot. JetBrains ran this benchmark with the same prompts, same agent configs, and no special tuning on either side. What I take from these numbers behind me is simple. When an agent is reading and writing Kotlin in your repo today, this is a configuration that gets most tasks done. And because JetBrains ran this benchmark, not us, you don't have to take my word for it. But more on this to come, don't you worry. In simple, Claude Code with Opus 4.7 at extra high came out on top by a considerable margin, because Kotlin is a language that we truly care about. In short, we're going to keep investing here together with JetBrains, because this community keeps showing us what great developer tooling looks like, and we want to empower you all. Claude is an amazing choice to write your Kotlin code, but Kotlin is also a great language to build AI-powered apps. Next, please welcome Vadim, who will tell us just a little bit more about that.
Morning, everyone. Let's talk about Koog, the Kotlin AI agent framework. Koog allows you to build fault-tolerant, scalable, and enterprise-ready AI agents in fully idiomatic Kotlin. Since its inception exactly 1 year ago, we have put a lot of work into it. We have taken your feedback and worked hard to improve it, fill the missing gaps, and fix the bugs. Thank you for all of your feedback. And today, I'm proud to announce the first mature, stable release of Koog. Meet Koog 1.0. Koog 1.0 is available today, and it's ready for building your AI agents in production. So, what does it mean? Well, whatever application you are building, whether it's mobile or a backend, with Koog, you can make it agentic. And as you can see, it's really easy to turn a banking application into a banking agent with just a few lines of Kotlin code. But that's not impressive anymore. For real-world production usage, you need scalability and you need control. And Koog is designed to give you exactly that. You can model precise graph workflows for your agents and express them using Koog's type-safe DSL with the guardrails that you can trust. And that's why Mercedes-Benz chose Koog for their vehicle maintenance support agent. Here is what they say. This is what Koog helps us build: structured AI workflows designed with modularity, traceability, and human-defined logic control. And this is the exact kind of philosophy that we had in mind when building Koog to solve our own AI engineering problems. Another fundamental problem with AI agents is that they are long-running processes that might fail anytime. And that's why we added Koog persistence that can checkpoint the exact node of the workflow and recover your agent from the exact same step in case of a crash. And you only need this amount of code to integrate it into your agent. And Koog is all about integrations. Take Spring, for example. With Spring AI, you get a great foundational framework supporting various LLM providers and more than 20 vector databases. So, where does Cook fit into that picture? Well, the good news is now you don't have to choose. Cook comes with full Spring Boot and Spring AI integration. So you can get the best of both worlds. You can use Spring AI as LLM and RAG integration layer, and Cook as agentic and persistence layer on top of it. You just keep your normal Spring AI config, and core abstractions from Cook will be automatically injected as beans, wrapping Spring AI, so that you can proceed developing your advanced AI agents with Cook. Since Cook was built in Kotlin from the day one, it works well with all your multi-platform targets: JVM, JS, Android, iOS, and even WebAssembly. On Android, we are launching local model support in Cook. You can use Google's Gemma models and build Cook agents that work even without the internet, right on your smartphone. Oh, but that's a clicker. On the back end, Cook supports a wide variety of integrations. Both Spring and Ktor, Amazon Agent Core Cloud, and key AI observability tools from major vendors. They can give you the insight of what your agent has been doing. You can see the exact messages, the visited graph nodes, and how much money you spent on each step. Cook works well with the tooling that is de facto standard in the AI community. So you don't have to switch the stack to build AI agents. Your backend, your mobile apps, your AI, all in one language, all in Kotlin. Cook 1.0 Cook 1.0 is available today, and no matter what AI workloads your company demands, we've got you covered. Next, I'm happy to invite my colleague Chantal to tell you more about Kotlin on the back end.
Good morning, everybody. We've seen how Cook integrates with Spring. Let's now look at how it fits with Ktor. Using the same lightweight structure you know and love, you can just install the Cook plugin, and it automatically detects any LLM providers from your configuration file. Whether you're using a file or configuring in code, any default agent behavior and features stays simple and centralized. And requesting the right agent for a task directly from your routes needs no extra wiring. You gain the flexibility of easily swapping strategies and models without compromising the type safety and predictability of your endpoints. Now let's say we want to share this agentic service. Ktor gives us a standardized way to do that. Built-in OpenAPI endpoints. Your routing code can now be automatically analyzed at compile time, and if you're relying on dynamic routing, even at runtime by using a DSL extension. And you can expose the generated specification using the interactive UI of your choice. Your documentation stays effortlessly in sync because with Ktor, your code is the source of truth. The Ktor and KotlinX RPC teams have also been working hard on a heavily requested feature that's now experimental for you to try. First-party gRPC support. By adding an RPC block to your build file, the KotlinX RPC Gradle plugin now detects services defined in protofiles and generates matching protobuf source sets. And if you're using a Kotlin multi-platform project, that means a matching source set for every supported platform. You can then implement these services and register them on a server that's bound to the lifecycle of your existing Ktor application. And of course, Just because I've said the word Ktor 6 times in under 2 minutes does not mean it's a requirement. If you want to set up a gRPC server in a standalone project, we've got you covered too. The next update, it's about Exposed, our Kotlin SQL library. After a lengthy effort and lots of reworking, earlier this year, the team finally celebrated its first stable 1.0 release. And with new skills, you can have an agent work on the upgrade for you. There's now a plugin to easily and safely generate migration scripts during your build process. And there's new SQL features like the vector type, so you can run AI-powered similarity searches without extra steps. Beyond our tools, we're committed to making Kotlin on the back end a great experience. And we're seeing the results of these efforts at scale. More and more companies are trusting Kotlin to build reliable products that we all use daily in more ways than many realize, even in heavily regulated and compliance-driven sectors. This is why we're choosing to provide releases with predictable support. Starting with 2.4, we're happy to announce that the Kotlin standard library comes with an 18-month security support policy. That means, for example, after 2.4's release date, any security patches from future releases within the 18-month window will be backported to this version, so you can plan your upgrades safely and on your own terms. From the start, Kotlin's been about creating resilient, readable code that improves the developer experience. And you can hear from teams that use it on the back end and get these benefits. And we're seeing the results of these gains with Kotlin at up to a 15 to 20% faster development cycle. That's less time from when you first change a file to when you push it for review, because ultimately, Kotlin helps maintain your productivity, especially as the complexity of your project grows. These gains go even further when we embrace how well Kotlin fits with existing tools from the JVM ecosystem. Spring tutorials already have great Kotlin integration, and now you're going to see Kotlin in JUnit documentation as well, because we've also been working with their team to provide more Kotlin representation. For all Maven users, we've been polishing our onboarding documentation and rolling out improvements for the Kotlin Maven plugin, meaning simpler configuration when you're setting up a project. If you're working with mixed Kotlin Java code, we're upgrading that experience too. For example, metrics. We're collaborating with the Micrometer team to better leverage Kotlin features and advance its library's coroutine support. And with our Lombok compiler plugin, you can keep calling Java decorations from Kotlin, no full rewrite needed, and it recently reached alpha and is now being stabilized with better annotation support. The same ecosystem you know, with Kotlin seamlessly in it. And lastly, our partnership with the Spring team continues to deliver first-party support from both sides, so you can experience the best of modern backend development on the JVM. And someone's here to show you exactly that in action right now. Please welcome Josh.
Thank you. Good morning, KotlinConf. Can you hear me now? Okay, everybody, quick, say open source. Thanks, everybody. My name is Josh Long. I'm so happy to be here. I come bearing good news. According to MIT last year, 95% of generative AI projects fail. Why is that good news? Because 5% succeed. And those 5% that do succeed, they succeed because they embed themselves in highly valuable workflows. You know where most of the highly valuable workflows are built? On the JVM, in languages like Kotlin, and in using frameworks like Spring. we have an amazing opportunity here, my friends, an amazing opportunity. We have an amazing opportunity. So we're going to talk about that and see how we can build production-worthy agentic systems and services using Spring AI and Spring Boot. Going, as always, to my second favorite place on the internet, start.spring.io. We'll build a new application. We'll configure the web support. We'll configure an AI model, in this case, Amazon Bedrock, though you can use any of dozens of different models. We'll use the observability support. We'll use MCP client support, and we'll use MCP security support, okay? Once we've got that, we can start writing the actual code. I'm in the IDE. I'll put some configuration pointing to an OAuth IDP. I'll configure observability and tracing. I'll configure a pointer to a remote MCP service that I'll use for scheduling a little bit later, and I'll configure virtual threads, and I'll configure the connectivity for my AI model. Once I've done that, it's time to actually start writing the controller. It's just going to be a stock standard Spring MVC style controller using a simple HTTP endpoint. I'm going to take advantage of Spring AI's chat client. And that chat client I'm going to inject via the constructor there, and I'm going to route questions from the user to this HTTP controller, and then route those questions onward to the model via the chat client, okay? And that chat client gets configured thanks to the configuration that we just saw a second ago. So again, this is just stock standard stuff. You've done this before. That chat client, by the way, just like any other client you've seen in the Spring ecosystem, like the JDBC client and the REST client and so on. Now, we have to configure the chat client. So to do this, we'll take advantage of a nice feature in Spring Framework 7, the bean registrar, which has an even nicer counterpart for Kotlin DSLs called the bean registrar DSL. We can import it just like any other configuration class. We'll define the beans accordingly. So here I'm going to configure the security for this application, for this little agent. I'll tell it to encode an OAuth token as it makes requests using MCP, and I'll define a bean by injecting the chat client builder and then dereferencing it to call.build. So there we go. I've got my built application there. I need to configure a default system prompt telling my AI agent what it's meant to do. In this case, we're building a fictitious dog adoption agency, so this system prompt basically tells it to do that, okay? And then finally, we're pointing it to our remote MCP service by injecting a pointer to something called the tool callback provider. Once that's all there, we're basically ready to go. Let's see what that looks like. We call this remote MCP service, which does scheduling. It returns a date 3 days in the future. And we're going to go to the browser here. We're going to log in to the IDP, you know, Josh and PW, don't tell anybody. It's going to redirect back. Look at that, 3 days in the future. The date comes back after authentication. So that's worked. We've got now an end-to-end call. And if you look at the code back on the MCP service, that is using Java code behind the scenes in Spring Security, but we have null restrictions because of JSpecify. This is a nice feature where Kotlin natively understands the null restriction annotations that we shipped in Spring Framework 7. With all this in place, we have a secure, null-safe, scalable, and observable system. It's also very fast. So here's the MCP benchmark that came out. I don't know if you remember February of this year. I don't, but it was very interesting. This benchmark came out and looked at different languages, the JVM, Go, Node, Python, and the awkwardly named fast MCP in Python. Well, the JVM was faster and had lower latency than every other ecosystem, including Node, including Python, which had almost 3 orders of magnitude worse latency. That's the fast MCP. Can you imagine the slow MCP, right? We have an amazing runtime. We have an amazing ecosystem. We have an amazing opportunity given where we are placed. And I think that's a good thing. And it means that more people are building more code, but we need good people who know how to integrate that and stabilize that. And this is being borne out by numbers in the job market. Just last month in April, I don't know if you can remember back that far, but just last month in April, in the US, we saw that there were more than 2 times as many job openings since 2023 for new software engineering positions. People are realizing that they need people to integrate all this code. There's an amazing time. There's an amazing time to be a Kotlin and Spring developer. Thank you so much for your time. Have a great KotlinConf, everybody. And now, welcome to the stage my friend Martin to talk about Kotlin multi-project.
Thank you, Josh. And hello, everyone. It's great to see you all here. So Kotlin multi-platform is everywhere now, and it continues to grow. In the last year alone, the number of top apps that use KMP has more than doubled. That includes companies like McDonald's, Booking, and Duolingo. So you're interacting with a KMP app, whether you're ordering a burger, planning your next big trip, or skipping your daily German lesson. On top of sharing business logic, more and more apps also use Compose Multi-Platform, our modern cross-platform framework for building shared UI with Kotlin. And we see this across industries. For example, the Sony Sound Connect app for headphones uses KMP to work with platform APIs like sensors and background processing, and they built the UI of their latest features with Compose Multiplatform. Or there's Perks Travel and Spend app, where they gradually adopted cross-platform UI in an existing code base. They started by sharing one small component, and now they rely on shared UI in several features. And we can keep going. There's Alipay doing payments, Kuaishou serving short-form video, and there's Tencent Video for streaming, all using Compose Multiplatform to power core features of their apps. With all these examples, Kotlin Multiplatform serves hundreds of millions of users every single day, which is fantastic to see. If you also want to build something with KMP, the good news is that it's easier than ever to get started, as the KMP IDE plugin is now available on all operating systems for both IntelliJ IDEA and Android Studio. And it gives you everything you need to build great KMP apps, with convenient run configurations, tools for working with Compose code, integrations with Swift, and, yes, even AGP9 support. You can also create new projects right in the IDE using the KMP wizard, which now uses a new default structure, where each module has a single, clear responsibility. This makes the projects easier to navigate, and it's also easier to modularize them further as your code base evolves over time. Next, let me show you how we're making the experience around iOS development better, because one of the nice things about Kotlin is that it fits seamlessly into any environment. On iOS, you can see this with Swift Export, where we already had a solid foundation last year, and we keep adding new features that make calling from Swift into Kotlin even more natural. The latest updates include support for suspending functions, which you can await as async functions in Swift, and flows, which can be converted to async sequences. So you can now work with coroutines across language boundaries. With all these recent improvements and all your positive feedback, I'm very happy to announce that Swift Export in Kotlin 2.4 is officially moving to alpha. We also introduced SPM import, which lets you add dependencies on Objective-C compatible code using Swift Package Manager. So you can import those packages into your Kotlin code in your iOS implementation and call into their APIs directly. This means you can use native iOS SDKs even if they don't ship a dedicated KMP package just yet. Last, but certainly not least, we know how important build times are for Kotlin native, and we have significant performance improvements here. Measuring it on the Google Docs codebase, we've seen 25% faster build times, with less than half the RAM usage during the build compared to just a year ago. These results are another great example of our collaboration between JetBrains and Google. And now, let's talk Compose. Compose Multiplatform is already fully stable and production-ready on mobile and desktop, and web has also moved from alpha to beta recently. So this is a great time to start building apps with shared UI for every rectangle that your users might want to see them on. For all these platforms, we continue to bring you the latest improvements and APIs from Jetpack Compose. The highlight of the last year here is the new Navigation 3 library, which is a flexible Compose-first solution that gives you full control over your backstack. And the best part is, it's already stable for multi-platform use. Beyond all these common APIs, we also have plenty of platform-specific improvements to talk about. Now, when it comes to working with UI on iOS, this last year has been clearly all about liquid glass. And with the flexibility of Compose Multiplatform, you can take real native liquid glass components and combine them with your Compose UI. One way to do that is to use our new interop APIs that let you render native views as an overlay above your Compose content. We also keep investing into optimizations for Compose Multiplatform. And in the latest release, parallel rendering on iOS is now enabled by default, boosting performance by up to 20% in complex layouts. On the desktop platform, Compose Hot Reload is now stable and built in, making it the default way of running your desktop apps during development. So you can go from code changes to seeing the results in a real app in no time, like adding this neat animated background, which you'll actually find in the KotlinConf app. You can also use your Compose skills to build web applications, which now have accessibility support and new interop APIs for embedding HTML content into your Compose code. So you can add things like useful interactive maps, engaging media content like that video, or perhaps some meaningful data visualizations to your apps, all by simply using existing components from the web. And while we're here, I also want to talk about Kotlin.js, which makes Kotlin work really nicely, not just with JavaScript, but with TypeScript as well. So you can use Kotlin to build SDKs that you ship to web users, or you can embed Kotlin code into your own web apps. To make this experience better, we shipped a ton of new interop features recently. And I'll show you just one of them in detail here as an example, calling suspending functions from TypeScript. To do that, you can annotate a suspending function with JS export, and the compiler will generate a TypeScript declaration for that function, returning a promise. You can then import that in your TypeScript code with auto-completion support, of course, and then simply await the result of the suspending function. This combination of Kotlin and TypeScript is especially nice, as you'll now have two compilers complaining when you make a mistake, which means you'll have valuable compile time safety even across languages. OK, with that, we've seen how Kotlin multi-platform powers a rapidly growing number of cross-platform apps, from shared business logic to shared UI, across all kinds of different use cases, and how it continues to evolve across all its platforms. But before we wrap up, let me highlight one more thing, our ever-expanding ecosystem of community libraries for KMP. There are now more than 3,600 of them listed on klibs.io, giving KMP users plenty of great options to pick from. So I wanted to take this opportunity to say that we really appreciate everyone who contributes to these libraries, which could not exist without your passion for Kotlin and for its community. Or, to put it simply, thank you. And with that, let me invite Seb back to the stage to wrap things up.
Right, everybody. Yeah, like I said in the beginning, there's a lot of things we got to see here, right? Kotlin really evolves across the board. We saw new language features. We saw everything from the Kotlin toolchain build experience, new LSP upgrades, AI tooling, AI partnerships, and now truly enterprise-ready Koog, right? We have better integrations on the server side. We have Exposed, we have gRPC, and then, of course, more transparent development and the multi-platform story with things like Liquid Glass in CMP, TypeScript interop story, Swift interop story, all of these wonderful things. You can probably imagine that this is a lot of work to put all this together. So please join me briefly for a hand and to congratulate all the people who've worked on this. And with that, you are ready for KotlinConf. We have our party tonight, and tomorrow you are cordially invited to our red carpet event, the Golden Cody Awards ceremony. And of course, as you go through talks, please make sure you vote for them so that we can keep creating a good program for you. Thank you very much. Make the most of KotlinConf and enjoy. Appreciate it.